Hello class, my name is Julian Sanchez and this is going to be an introduction to Java collections. What we're going to be talking about is, of course, what are Java collections. So we're going to be a good overview of what this is, what these are. Then we're going to be getting into, the different types of Java collections. So, we're familiar with arrays. There's we have lists very similar to arrays, but functionally a little bit differently. Um, then we have our queue interface that we're going to be talking about. Then we're going to be introducing the concept of recursion and how to use recursion with methods that call on themselves. Um, and binary tree to store information, another type of Java collection here. But let's get right into it. So what are Java collections, right? So by definition, this is a framework of a single unit of objects that provides an architecture to store and manipulate such objects. So what does this even mean? Basically, this just means that we have a structure that allows us to store several objects of the same type, right? So this allows us to search elements. We're allowed to sort and insert and modify and delete them as well. So different ways to be able to manipulate them. They have to be the same object type, right? So if you choose string, it can all be string. If you create an object, right, it would have to be all of that same object type, right? That's what it means by a single unit. So essentially, with our interface, we do have different interface types that allow us to do exactly what we're talking about, right? The two ones that we're going to be talking about are lists and queues. We also have dequeues and singular sets. We're not going to be talking about those, but these are just to show you that there's several different types as well. And also we have different classes that we can already use publicly. We have ArrayList, we have LinkedList, we have all of these as well here, but we're going to be talking about array lists and linked lists. So to start off, we're already familiar with arrays, and now we're going to be talking about lists, which is a newer concept here. So arrays, we already know that this is a data type that stores a fixed number of elements, right? So we need to know in advance the number of indexes, elements, or rows that we're going to be needing. And it's always going to be contained with a fixed size, right? We can't really add another one. We can't remove them, or we can modify the ones that we already have, right? But we can't make it grow. We can't make the size smaller. An example of this would be, if you're implementing something for test grades, right? A professor will oftentimes have a set number of test grades set out for their students. Same thing with a dozen of donuts. We already know that that's going to have 12 donuts. Um, Now, of course, when it comes to a list, this is what we want to be using whenever we're going to be working with data sets that have varying, number of data, right? Keep in mind that this is an interface, right? So there are going to be classes that implement this interface, right? So once we understand lists, we're going to be talking about the different classes that implement the list interface, right? But basically what these allow us to do is we can insert information, we can remove from any position in the list, right? And examples of this, is if we're making a code for applications for university. These applications are going to be constantly coming in, so we don't have a set size, right? We're not going to want to use an array for this. Same thing for inventory. At a retail store, we're constantly adding more inventory. We're constantly removing inventory. So an array would not be ideal. You would want to use some type of list or some class that implements the list interface, right? So essentially, again, as we've just mentioned, a list is an interface, right? It allows us to insert positions, insert and search from different positions, modify them, of course. And so, yeah, visually, this is what's going on here. So, an array, we already know, right? We can't really make it smaller, make it bigger. Array list is very similar visually, right, to an array list, um, where you have these elements here. You can access them using different elements. Only difference is we can add another element here. We can add element 5. I'm sorry, we can add element 6, and then we can add 7, 8, 9, 10, and then we can remove 1 and make it smaller again. We can remove all of these right here and make it just 1 and 2, right? We can't do that with an array. A linked list is a little bit different, right? So every little block here is what we call a node, right? And a node always consists of an element, which is the data that you're working with, and a reference to the next element, the next node, right? So that's how they're linked together, right? So the first element has access to the second one, the second has access to the third, blah, 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 so on and so forth. So let's understand really quickly the list interface methods, right? So these are the methods that we're going to be using with all of these classes that we just talked about, both of these. So to start, we have two different types of add methods. One that takes just an element E, whatever object that is that you're working with, right, and returns true or false if it was able to add it or not. Um, Another add element, you're able to specify which index you want to add it at, right, and which object elements you want to add. It's just going to add it there. It's not going to return anything. It's just going to add it at that position. Um, we have two different types of remove methods. One where we can specify which index we want to remove, and it's going to return the element that we're removing. That's E stands for element. And of course, here we can specify which objects we want to remove, right? It's going to find it and return true if it was able to remove it or not, if it is present, right? Clear really just removes all elements from the list. So we call this and everything is cleared off. We no longer have access to it. And notice how this says void. We will lose all this information if it's not already saved, so you have to be careful if you need to know if you need to save your information or not before using this. But when it comes to contains, right, this is you insert the object that you want to look for and it returns true if it's contained within the list, or false if it's not contained in the list. Here, this is a handy tool that allows you to get an element at a specific index that you're looking for. It's going to return the element if it is, the element that you're looking for in that specific index. Um, from there, the last thing that we want to know is the size method, right? This just basically returns the number of elements in the list. Very similar to the length of an array, right? But with the size, given that this is constantly fluctuating, we want to use a size, right? Um, List interface methods typically don't have anything for length. So now that we have an understanding of lists, let's talk about more in depthly how array lists and linked lists are actually storing information, right? They're both doing the same type of job, right? Because they implement the same methods as list. The difference is how they're storing the information. So an array list still in a way is using an array, right? But it's using an array that can grow if there's not enough space, right? We're still using index numbers to locate and search for different elements, right? So we can find index element 2, index element 0, 4. We can go back and forth, right? We can access it at random. And if we needed to add another element, boom, then we would just have index element 5, and then if we needed to add more, so on and so forth, right? We can keep growing to this list, right, if there's not enough space. For a linked list, these are always, of course, like we mentioned earlier, that they're linked together. So each element has data and a reference to the next element, right? So in this case, we're storing 2, and it's pointing to the next element, which is storing 23, and it's pointing to the next node, which is storing the letter A, points to the next node, which has the letters DD, so on and so forth. We know we've reached the end when it's pointing to null, right? Because there's nothing left at the end of the tail. This is what we mean that we must traverse from head to tail, right? So we cannot just say, oh, let's go here, right? No, we don't have direct access to this. We have to go from the first head to the next node to the next node until we find the one that we are looking for. So conceptually, this is how we're accessing and storing information, right? Typically, when we're adding elements, we add at the end of the tail, or we can specify where we want to add an element, right? By going from here, 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 and then inserting it. Boom. So that's visually what these are actually doing. Let's talk about more specifically how they're doing it. So with an array list, right? This is what I mean by an array list that grows, and if it doesn't have any more space, right? So this right here, this array was filled, and if we needed to add another element, it's just making another array with double the size, copying each of these elements into that new array, right? And now we have space for more data. So this is how it's doing it. When we first create an array list, if you don't provide a specific length, it's going to create a length of 10 by default. Um, The length of the array is going to be indicating the maximum capacity, right? This was a capacity of 4. This is now a capacity of 8, and now we only have 4 elements, so there is more room to add. And of course, like I mentioned, when the capacity is reached, the elements are copied to a new array. The size method, like we mentioned, is the number of elements, right? And so in both of these examples, this is a size of 4, um, length of 4, length of 8. However, you will not be using the length method um, with ArrayList here. So, and again, like mentioned, you're able to use index location at random to find these elements. So now that we understand what an array list is doing, let's go in and actually start off by showing you how you're actually going to code with ArrayList. So before we start going in and talking about how we're going to code with ArrayList, let's go over the family member class that we're going to be using throughout all of our examples throughout this video. So family member class is basically a class that I created that is storing a first and last name of a family member, right? Our constructor basically it just takes a string of a first name and a last name and sets it as this object's first and last name. And of course we have our setters to set the first and last name if we wanted to change it. We have our getters if we needed to get the first and last name, and I overrode a toString method here to be able to print just the first and last name whenever we needed to print it easily. Alrighty, so let's get right into it using an array list, right? So I've created a method that is going to walk us through how we're going to actually be creating an array list and how we're going to use these different methods that we talked about earlier. So first thing is, of course, we need to create and we need to initialize our array list, right? So this right here is creating an array list with a length of 4. We use our array list key phrase, right, to indicate this is the type of object that we're going to be creating. And we need to indicate the type of object that we're going to be storing within this structure. So we're indicating that we're going to be using a family member object. We're naming it a Christmas family list because we're going to use this to indicate, a list of family members that we need to get gifts for Christmas. And then we need to use our new key phrase to, of course, create a new object of this. And this is where a constructor comes in. We use the name of the object, or I'm sorry, the type of object array list that we're creating, holding the family member object that we're storing in brackets. And here we can indicate the length that we want. We can do several different things. If we leave it at 0, it's just going to create a default length of 10, right? And this is really just, you want to keep in mind how much capacity you want initially before you have to duplicate. So obviously if you're working with a very large data set, you want to create less work for this. So you want to create an initial length of a larger amount. In our case, we're not going to be creating a very long list. So we can use just 4 before it has to duplicate and, create a new array and copy all of its elements into it. So we can keep it simple at a length of 4. So let's see what happens when we just try to print this, right? I've created a method that's just going to indicate, if it's empty or if it has elements on there, it's going to print information regarding those elements. So in this case, we provide this Christmas list. It is empty, right? There's nothing in there because we haven't added anything. So let's go in and add some elements here. Christmas family list dot add. Let's add, because we have to add family member objects, right? So we have to add a new family member object. So given our constructor for a family member object, family member, we have to provide a first name and a last name. So we have added a new person to this list, right? So now let's see what happens when we print this. Now at index 0, we have Homer Simpson, right? Say we wanted to fill this list with all 4 people, right? Let's add 3 more, and let's add Marge Simpson. Now let's add Lisa, and let's add Bart. Now we have added these people to our family list, and let's see what happens when we add another person, right? Let's add Maggie to this here, the baby, right? This doesn't pose any problem at all. We can still add this element here. The only thing that happened is the back end, this had to create a whole other array and copy everything into it. So now this technically has a capacity of 8, right? We can store 3 more elements before it duplicates into another one, so on and so forth. So um, that's how we add elements. Now let's go in and see how we add elements at a specific index, right? So I've created a couple of lines of code beneath this here. So say we want to say we want to find or add an element at index 2, right? So we're going to be adding Abe Simpson to the list at this specific index. We're just printing this right here, right? Abe Simpson is Homer's dad, right? So we're going to be going to our Christmas list, adding at our index, which is 2, and we're adding a new family member, which is Abe Simpson, right? Then we're just going to be printing this list again, right? So let's go ahead and let's do this here. Adding Abe Simpson to the list at index 2, right? So he should be at index 2 now, right? Everyone else was shifted over, right? So before we had Lisa, Bart, and Maggie, right? Now after Abe is Lisa, Bart, and Maggie. So everyone else is shifted over, and now we have that element in there at that specific index. So that is how we're going to be adding methods. So here I've created a separate method that is taking the same list that we created as an argument, right? So we're still working with this same list, just a different method that is executing and showing us how we're going to be modifying an array list, right? So how we do that is essentially, let's say we want to remove an index at, or remove the element at index 3, right? So I've created a print statement that is printing, which index we're going to be removing. And this right here is doing two things, right? Of course, it's removing the index, right, at this specific, removing the element at the specific index, but it's also printing it as well, because remember, the remove method is returning a family member object in our case, right? It's still returning the object that we're removing, and because we're returning the object, we're sending a reference to it, we're able to print it, right? So in this case, it's just going to print the first one. All right, so let's run this. Perfect. Okay, so our print statement is saying here within our console outbox, right? We're removing the element at index 3, right? So that was originally, this is our previous list, right? At least the list that we had sent over. So index is Lisa Simpson still, right? So we're removing her from the list, right? That means everyone is shifted back up to wherever Lisa was, right? So now in place of Lisa is at index 3 is now, should be Bart because he was next. So, and as we have right here, right? It is now at index 3 Bart, so on and so forth. So everyone is shifted up. We can keep doing this as well. Of course, if we're just removing it, we're not printing anything here, so we're not going to be able to print anything. So let's just say we want to remove the index at 0, right? After this, once we print this, Homer should also be gone from this list as well. And there he is. Now he's gone, and now we're left with this list here. That's pretty much how we're able to kind of modify the list. Of course, if we wanted to actually change the element, we would access it using the get method, and then once we have access to it, then we can modify it however we need to. But yeah, that's essentially how we can modify our array lists. Now that we know how ArrayList works, let's go into talking about linked lists, right? So a linked list, as we previously mentioned, every linked list has a node, right? And a node is composed of two main functions. It has a data that we're actually storing and a reference to the next node. This is shown right here, right? So this is the head, the first node, right? It's pointing to the next one, to the next one, to the next one. And each node has the data that it's working with and the reference to that next node, right? Everything is starting from the head and ends with a reference to null at the tail, right? So this is the tail because it's pointing to null. This makes it much more easily for swapping and removing elements by relinking nodes. Right, so we wanted to remove, say if we wanted to remove this one, right? All we'd have to do is just point it from here to here, and that's it. There isn't any more reshifting of all of the other elements over. It's so much more efficient for frequent removing and inserting elements in the list. Keep in mind, however, that you can only access these elements from head to tail. You have to go from beginning to the next one, to the next one, to the next one, to the next one, all the way to the tail, right? And It is important to note that whenever you're working with lists, you must use a reference node to traverse through the chain, through the linked list, right? That's what I mean by chain. So essentially, when you're traversing through the nodes, what you do not want, before we go into that, you need to understand that, again, you can only access each element by traversing through it from head to tail, right? Each node only has access to the next one, right? So given that, what you do not want to do is you do not want to move the head and start going to the next node, over to the next one, right? Because remember, you only have access to the next one, right? So if you move the head, you now lost access to this one, right? Because we moved it from pointing to this one to pointing to this one instead, right? So you must preserve the order of the chain by creating a separate reference node that points to the head, right? So you have your list object. Now you have another reference node object that you created separately. And that's what you use to point at the head. And then you can use it to go to the next one and go to the next one. That's essentially conceptually what you want to be doing to actually, use this information. So now that we understand conceptually what a linked list is doing, let's see how it's doing it in code. So to demonstrate how a linked list is working, I've created a class that simulates what a linked list is doing. So that way we understand the code behind a linked list, because if we can understand how a linked list is working, then we also understand how to work with nodes as well. And it's very useful to work with nodes in general, right? In this case, nodes are being used to create a linked list. However, you can use nodes for any given purpose as well that you deem to. So let's get right into it. So as we mentioned, every node, which is the linked list object, has two pieces. It has a data, which we're using as a family member, that we're naming it as a person, right? And it has a reference to the next node, right? The next RSVP linked list. We're using this class to create an RSVP list of family members that are attending a wedding, essentially, is what we can use this for. So our constructor, of course, is the name of the object of the class type, right? So RSVP linked list. And we're just going to be providing a family member named, a family member person as the object and setting it as the person. And so here we do have our setters and getters, everything here. So of course we are able to set the next list, the next item on the list. If we wanted to, we're able to clear it. Again, this returns void, so we will lose the information. And essentially we have our getters, so we're able to get the next element, and we're able to get the person within the actual node itself if we needed to. I created a toString method that is going to print everything on here. We're not going to go over this right now, but this is just printing every element on here and provides the position and all of that. So now these are very important list methods to understand how these lists are actually storing and accessing information, right? So the methods that we talked about earlier, remember, they're both doing the same job, but they're doing the job differently. So we're going to talk about how we're adding, getting, and getting the size, right? So to start off, let's go in and let's just see how it's actually adding elements, right? So when it comes to a linked list, it's always adding an element to the end of the list, right? So we have to start from the beginning, we have to go to the end of the list and then add it there. So as far as how it's doing that, what we need to do is, of course, like we've mentioned before, reference. We have to create a separate reference node equal to the head of this list, right? So we can use my cursor as the actual reference node, right? So we're setting it equal to the head of this list, right? And then what we're going to be doing is, while the reference next node is not equal to null, right, we're going to proceed, right? So the next node is B, right? So it is not equal to null, right? So we can execute with this line of code. And what we're doing is we're just making the reference equal to the next node, right? So the next node is B, so we're making the reference equal to the next node. So now we're here. The loop repeats, right? So while the next node is not equal to null, right? In this case, it's C. C is not equal to null, right? So we do proceed. We go to the next node again, right? Now we're in C. Now we're in this position over here. The loop repeats, right? The next node is D, right? So it's not equal to null, right? D is not equal to null. So we do proceed and we go to the next node again here. Now we're here. The next node now in this case is equal to null. So this is no longer true anymore, right? So we're exit out of this code. It's no longer valid. We proceed to the next one. And all we're doing is we're now setting the next node equal to whatever person we've provided as a method, right? So now instead of it pointing to null, it's going to point to whatever new object that we created, right? And because of the way our constructor is created, whenever we create a new person, it's pointing to a null, right? The next node is now null, right? So it's also creating a new object and it's also creating the tail, right? So D would be pointing to the new object. The new object would now be pointing to null. So let's go in and see how we're actually getting an element from a specific position, right? So to start off, we do want to set a reference, but in this case, we're going to set it equal to null because we still want to check to make sure that this is still a valid position, right? So a valid position would be if it's greater than or equal to 0, right? We don't want to enter anything that's in the negatives. And we want to make sure that the number is smaller than the size, because if we enter anything bigger, if say the size is 10 and we want to find position 15, that doesn't exist. So as long as it's a correct position, then we can set the head of this node, which is going to be my cursor over here. And then we're going to do this traversing slightly different, right? So say we want to find position 2, 0, 1, 2. We want to find this one over here, right? So if we want to find position, right? So while 2 is greater than 0, right? That is true, so we can proceed. We're going to update the reference to be the next node, so it goes from here to here. Then we're going to lower the position by 1, so we go from finding position 2 to 1. We restart. Position 1 is greater than 0, so we go to the next node, right? So we were originally here, now we're here. We're going to lower the position, so it goes from 1 to 0. We restart. 0 is not greater than 0, so this stops, this terminates, and we return the reference, which was at C, or at the position that we wanted to find.